Namaskara. I am Rudresh TK, working as a lecturer in Department of Electronics and Communication in Government Polytechnic Company. In this session, I am going to explain about the electronic symbols used in fundamental of electric and electronics laboratory. First thing is wire. So wire is used for bring up of circuit or connection of a circuit diagram in a laboratory. There are different kinds of wire available in laboratory. One is called single strand wires, and this is called multi-strands wire, and this is called cable. In a single strand wire, there is a single conductor surrounded by a insulator, and in a multi-strand there are multiple conductor surrounded by a single insulator. So you can see the wire in a picture, and you have a cable in the sense there are multiple wires bundled together as a cable. So these are all the different kinds of wire we used in our laboratory. And probe, this is a ready-made probe, and these are all used in a trainer kit. There are some trainer kits this used to connect one point to another point. Here I have a different color code. One is a red color, another is a black color. Each color have a polarity representation. These are all we going to use it in our laboratory. Then while writing the wire in a circuit diagram or in a schematic diagram, they are using like the single line. It's a wire. If they have multiple wires connected on a single point, they use the dot. Here you can see the dot is represented as a connected wire, and you have four wires connected in a single dot. That is a single dot is represented with a four wire, and the not connected is just a line. There is no dot. It's in the sense there is not connected. This is the wire symbol we used in our circuit diagram and schematic diagram in our laboratory circuits. And next important component is fuse. The fuse is used as a protecting element. You can see this is a fuse. This fuse which protects the device from the current, maximum current. If the device have a maximum current, then device get burn out. For that protecting element, they are using the fuse. Here you can see the above picture, the fuse is burned out. The means it get damaged when you when maximum current flows in these fuses, the fuse will get burned out. See, the fuse consisting of a single thin wire inside. You can observe this thin wire. Whenever the maximum current flows through that thin wire, the wire have a low melting point. That means the wire will get melted and it will break the circuit, and it protect from the maximum surge in a current. So this used as a protecting element, and you can, it is an enlarged image. You can see the fuse, and there is a, this fuse have a different rating, different current rating. There are few 100 milliamp, 500 milliamp, 1 amp, 2 amp. It's a current rating. It's mentioned in this in the fuse. And this fuse symbols, the fuse symbols is written like a rectangular box with a single line draw is called as a fuse, or some textbook or somewhere it is used as a two dot connected with the wire, that is called a fuse. This is the symbol we used in our electronics laboratory. And next component is cell and battery. See, it's a power cell you have used in your home appliances, like power up of a torch. You are using a single cell, and it's a DC power supply. It's our polarity. There is a positive and negative. It is symbolically represented as a one straight line with a longer the straight line and the shorter the straight line. The longer line represented positive polarity, shorter one represented the negative polarity. This is a symbol used in a cell. And battery means it's a collection of the cells. There are multiple cells connected together formed as a battery. There are different kinds of battery available in electron laboratory. There is a, this is a UPS battery. It's have a series of cells connected connected one by one. That is called as a battery. And there are single cells is connected there are multiple cells connected in a single battery. It's like you can see that the volt current rating, it's a 1500 milliampere. It's a 3.7 volt. These are a lithium ion battery, and you can see 9 volt battery. This battery have a multiple cells. So this is a battery, and symbolically the battery symbol is written as a collection of cells. Cell is written one longer straight line and one short straight line. Here in battery, it's a multiple cells connected together is called as a battery. The battery also have polarity, one is a positive and negative. This is a battery symbol. And coming to voltage source, there are two types of voltage sources. One is a DC voltage source, another is a AC voltage. DC means direct current voltage source, alternate current voltage source. The DC voltage source is represented as a cell. It's a battery. All the batteries provide the DC voltage source. You can see here it's mentioned as a DC power supply. This is a DC voltage source, and it's a ground point. If all the circuit negative point is connected one common negative, then that common negative is called as a ground. This is the ground point. The symbol used for a ground is a 3 horizontal line. And AC symbol, AC voltage source. For AC voltage source, circle, inside the circle it's written as a S. This is called as an alternating voltage sources. There's a symbol. And AC and DC voltage sources, it's like everything is written in a single slide. This is a single cell, and it's a battery. Multiple cells connected together is formed as a battery. And DC voltage source, somewhere it's written as positive and negative with a V, it's a DC voltage source. Or somewhere this single cell or battery itself is a DC voltage source. And this is AC S. If it is written S, sleeping S, then it's a AC voltage source. And next, coming to switch. Switch in our home, we have seen multiple switches. Here it's used in electronics appliances like your spike booster or some smaller electronics item. It's the switch inbuilt have a LED. Whenever you switch on the switch on, this LED will turn on. Whenever you switch off, this LED will get, there is a LED indication inside the switches. There are different kinds of switches available. This is called toggle switches. And there is a push button. You can see here it's a push button. And these are all the different ways of switches is available. And while writing in a circuit diagram, this is the symbols you use. This is like a straight line with a 45-degree inclined line with no connection, that is called switch. And somewhere it is written two dotted with a slightly inclined line, that is a switch. And it's push button. If you have a T, tilted T, then it is called push button. Switch have two kinds. One is a open switch, another is a closed switch. When the line is open, means there is no connection, that is called line is open. It's a open switch. And if the two dotted are connected with a single line, that is called closed switch. These are all the symbol we used in our circuit diagram. This indicates the switch symbol. Then coming to resistor. Resistor is used as a current limiting circuit, current limiting component. These are all the resistors available in our laboratory. You can see the different colors, bands in surrounded with the resistor. You can observe different bands. Each band, each color band have a meaning. And these are all the different kinds of resistor. And you can see the wattage rating. Wattage rating is power wattage. This can withstand up to 1/8 watt, 1/4 watt, 1/2 watt. And these are all the 1 watt, 2 watt. And whenever the wattage is increases, the size of the resistance will get increases. See, you can observe 1/8 watt resistor is a smaller resistor. And if you see the 5 watt resistor, the larger the size. 5 watt 22 ohm. And this is the size of the resistor says 22 ohm. This is symbol used to represent the ohm resistance value. And see, there is another kind of resistor. This is having a power resistor. It's having a more power withstanding. It's have 5 watt resistor. And there is a one more 5 kilo ohm with a 5 watt resistor. The size of the resistor is increases. And here it's a 25 watt resistor. The more the power, the size of the resistor will be increases. These are all the different sizes. It's a comparison. You can see it's a small size, and the size is keep on increasing as the power rating is increases. These are all the resistor we used in our laboratory. And the symbol used for writing in a circuit diagram, this is a symbol for resistor. And a resistor have two kinds. One is with arrow mark, without arrow mark. There is a without arrow mark. This indicates this is a fixed value, fixed resistance value. And with the arrow mark, it's up, it says variable. Variable means there is a range from lower to upper range. The resistance value can be changes from the low to upper. For example, 0 to 100, the value may be anywhere in between 0 to 100, that is called variable. And if it is 10 or 100, it's a fixed value. This is the symbol used for a fixed resistor, and this fixed and variable resistor. And in some textbooks they use rectangular box, it says a resistor, and a rectangular box with the arrow mark, it's a variable resistor. And this is a unit, we call that as a ohm. The you are seen in the diagram, it's 22 ohm. This is a unit we used. I'm going to explain this in a detail in the next coming session. And the resistor color code, each I have told, each resistor surrounded with a different color band. There are different 4 bands available in each resistor. The first band represented first digit, second band represents second digit, and the third band is represented third multiplier, that is a 10 to the power of multiplier. And this is for tolerance. There are the only 3 color, gold, silver, and no color. Each have a tolerance, each will have a unique value. This will going to see it in a next table. So this is a color code representation. This is the first digit, means if it is a black, it's a 0. And if it is, for example, here it's having a brown. See here, it's a brown. What is this mean? Brown means 1. Here it's written 1. And here second band have a red color. The red indicates 2. It's a 2. And it's a multiplier. Multiplier means it's a brown. Okay, brown means 10 to the power of 1. That is a 12 into 10, it's a 120. That is a 120 ohms. And here it's have a gold color. Gold color means it's a tolerance. Here it's a gold color 5%. That is a 5%. This is the value of resistor, 120 ohm resistor. And here there is a below, you have 5 bands. Okay, see in this 5 band, it's a first band, it's a first digit. First digit has a yellow color. Yellow color is means 4. And second digit is it's a violet. Violet means it's a 7. It's a 7. And third digit is a black. It's a 0. It means 10 to the power of 0. Oh sorry, it's a third digit is a 0. And multiplier means it's a brown. It's a 1, 10 to the power of 1. 470 into 10 to the power of 1, that is a 47. 470 into 10, that is a 407, 4700. It's indicated as a 4.7 ohm. And last one is a brown. Brown indicates 1% tolerance. This is called as a color code. To remember this, we are using the BB Roy went for a there is a one saying, BB Roy, the BB Roy, ROY Roy, went to Great Britain. Okay, have a very good wife. So this is a saying to remember this color code. And to find out the value, we'll see it in a detailed explanation in coming sessions. So just remember each color have a value. For that I am showing this color code. Next device we call that as a capacitor. Capacitor is used to store the charge. Here it's called as a ceramic capacitor. It's written 104. I'm going to explain how the value will going to calculated for the ceramic capacitor. You can see it's a smaller the value ceramic capacitor. And you have a different kinds of capacitor. This is called electrolyte capacitor. Here it's a negative, minus it's represented, and it's a white strip. There is a band on this capacitor. It's indicated a negative polarity. And here also it's called electrolyte capacitor. Electrolyte capacitor have a polarity. One is negative, another is a positive. Negative polarity terminal, usually it's a short compared to positive polarity. And this is for ceramic capacitor. And it's called condenser. It's also called capacitor. We are using it for a fan and motor. It's acts as a charge storing element in your home appliances. You can see the fan having this kind of capacitor. It's larger the size. Larger the size means it's a smaller the value of capacitor. And in our lab, these are all the different kinds of capacitor we used in our circuit. It's a ceramic capacitor. It's called electrolyte capacitor. Here it's a white strip. having a negative polarity. Here you observe this negative polarity terminal have a shorter than the positive polarity. Each capacitor have like this, but ceramic capacitor doesn't have the polarity. Electrolyte capacitor have the polarity. Larger the capacitor value, uh, is a larger the size. Here the smaller the capacitor value, smaller the size. And the capacitor symbol, the two parallel line is represented as a capacitor symbol, and sometimes it is written like a C, that is indicated it's a having polarity. And somewhere it is written a positive. Positive means it's a polarized capacitor, and somewhere it is written horizontal line, arrow line, it says the word variable capacitor. All these are fixed capacitor. These are all the capacitor. And here the for computation of ceramic capacitor value, this is the calculation. It's a 10. There is no digit on this, then it says that 0, 10 to the power of 0 means 1, that is a picofarad. And here 10 to the 101, that is a 101. 101 means 10, 10 into 10 to the power of 1, this is called power. Here you can say 10 104, in this case 10 written with 10 to the into 10 to the power of 4. 10 to the power of 4 means it's a 4 zeros into picofarad. This is nothing but a, this is the way calculating the ceramic capacitor value. But for electrolyte capacitor, it is printed on this capacitor value. Here you can see there are some printed characters. It's written 1 microfarad. The value is printed on this electrolyte, but in ceramic capacitor it is printed like this. And next, coming to inductor, these are all the inductor device. It's like a surrounded coil surrounded with a conductor. So surrounded with the coil is called as an inductor. These are all the different inductors, and you can see this is a coil having a inside having a inductor, and this is also coil. This is act as an inductor symbol. It's like a coil, it's written as a coil. And there are different kinds of symbol. It's just a coil, then it's called air core inductor, means air surrounded with the air. If it is like a two line, that is iron core inductor. The core have a iron. So you can see this is a inside, it's iron. See, that is called iron core inductor. And a ferrite core inductor, ferrite means magnet, it is like a dotted line. If it is have a dotted line, it's a ferrite core inductor. Then variable core inductor, there it's a arrow mark, it's indicated variable core. This is the inductor symbol. And next, coming to transformer, while using the we are using for building up the transformer, they are using the inductor concept. This is a transformer looks, red line, red two lines, this is for input. They called AC voltage is connected to the input, and there are output line three output line represented the AC voltage. The transformer have two types, one is step down and step up. Step down transformer usually converts the your input value and lower output value, but step up lower input value, maximum higher the output value, that is called step up. See, this is the step up step down transformer. AC input is connected, this is the output. This is the way it work, we're going to explain in coming session. And how this will be made up of, it's having a coil. There are two coils, one is primary coil, another is a secondary coil. You can observe this. So in a magnet you can see this is the primary coil and this secondary coil. See, this way step up and step down can be happened in a transformer. The symbol is written like a coil, have a primary and a secondary with a single line, that is a single or multiple line, that's a linkage of flux from the primary to secondary. It is represented with the two lines. This is a symbol, transformer symbol. And next is a diode. These are all the diodes used in an electronic circuit to build applications. So this is a one type of diode. Is a black color. One side have a white strip. You can observe this is the white strip. This is IN4001, the diode. The white strip indicated it's a cathode, negative point, and the black strip is connected as a anode point. This is a symbol of diode. And this is a BY147 diode. There is another kind of another specification of diode. You can see there is a one side it's a flat, another side is having a curve, circular shape. This is called cathode and this is called anode. This is negative and this is positive. And these are all the different types of diode. You can see different sizes. Different sizes means different power handling capability we used in our electronics laboratory. This is the symbol. It's a written like this, diode symbol. And coming to LED, that's a light emitting diode. The advanced features of the diode is a light emitting diode. These are all the diode version, but it emits the light. Okay, so you can see different kinds of diodes. All these are two terminal device only. There are, if you see resistor, capacitor, inductor, diode and LED all have a two terminal. There are two connecting points. That's a terminal. Each have one is positive, another is a negative. If you observe this, there are length. If you observe the length of the two terminal, one is having a smaller the length compared to another one. Like what I discussed in a electrolyte capacitor, like this, it's have a different kinds of LED. And see here, the shorter the length, it's a negative, that is a cathode. The longer the length, it's anode. The symbol, it's same as a diode, but it's a two arrow mark written. The two arrow mark, it indicates the emitting of light. That is a light emitting diode. It's anode and cathode. Somewhere in some textbook it is written like this. They have written circular and arrow mark, it's indication of LED. This is the LED symbol we used in our electron circuit laboratory for drawing the circuit diagram. Then coming to transistor. Transistor is a three terminal device. Till this point I have discussed about two terminal device, and now this is a three terminal device. It's a transistor. It's a next version of diodes. The next advancement is a transistor. It's have a three terminal. You can see all this the transistor, different kinds of transistor. Some of them are made with the plastic, some of them are made with the metal. The metal having act as a heat sink. It absorbs the heat from the transistor and emits to the external environment. That means it's make it it acts as a heat sink. And this is symbol, transistor symbol. There are two kinds of transistor. One is a NPN transistor and PNPN transistor. NPN transistor means arrow mark outside. The circle have a three terminal. If the arrow mark is pointing outside, that indicates NPN transistor. If the arrow mark inside the line, then it's a PNPN transistor. The three terminal have a name, that is a base, collector, emitter. You can see it in a graph. And next, coming to voltmeter. See, whatever I explained till this point, all these things are all the component we are used in electronics laboratory to build the circuit diagram. See, after building the circuit diagram, we need to measure the voltage value and current value. For that, we are using some meters. What are the meters we are using? Voltmeter and ammeter. Voltmeter, so this is the voltmeter which used to measure the voltage in a particular point. Okay, so this is called DC voltmeter. How we call DC voltmeter? In a volt, we indicated voltmeter. Here it's a straight line represented DC. Here is having school 0 to some 2 and 10. This is the needle, and this is a connecting point, it's a negative point, and red indicated the positive, it's a 15, and it's a 3 volt. The lower scale, it's a 3 volt. If you connected here, it's a upper scale 0 to 15. So this is the having a multiple voltage range can be possible with the DC voltmeter. And there is only 2 point. One is negative black, another is a positive, it's a red color. It's a range from 0 to 10 volt. It's a DC. If it is a straight line, it's represent DC voltmeter. And there is a AC voltmeter also. Voltmeter, we indicated voltmeter in below. If they are written like S, tilted S, you can observe this V and tilted S, that indicates AC voltmeter. Its range from 0 to 450 voltage can be measured. In this meter, 0 to 150 voltage can be measured. And there is a two range. One is a upper, another is a lower, 0 to 15. Here it's have a two positive point, another is a one negative point. If the wire is connected in between these two, 0 to 15, then lower the scale measurement. If it is from 0 to 150, it is upper the scale. This is called AC voltmeter. And symbol, circle, inside the circle if they written V, that indicates it's a voltmeter. And polarity should be is very important, otherwise the output reading will say is negative. And if they written V tilted S, it's indicated S, that is AC. And if it is a straight line or a dotted line, it says DC. This is the voltmeter. And there is a coming to ammeter. Ammeter is used to measure the current in a circuit diagram. There are different types of ammeter, as I have I had explained in a voltmeter, same thing like a DC ammeter and AC ammeter. In a DC ammeter, there are different range: microammeter, milliammeter, ammeter. So this is MA, small letter M and capital letter A. It indicates milliammeter. It measures 0 to 100 milliammeter current. This is a black indicated negative, red indicated positive. This is a milliammeter used to measure the current in a circuit diagram. And this is A, direct straight line. It indicates the DC ammeter 0 to 10. It measures from 0 to 10 amp. It's a negative and positive. And there is a AC ammeter also. A, if they have written A with the tilted as its AC ammeter, it measures from 0 to 30 ampere. And there is a one more ammeter. It measures from 0 to 5 ampere along with 0 to 1 ampere with a different connecting point. It's a AC ammeter. The symbol for AC ammeter and DC ammeter, it's the same. Circle along with the A, it indicates the ammeter. Next is multimeter. Multimeter means it's a combination of ammeter, voltmeter, ohm meter. All the things is measured in a single meter. That is called multimeter. We can see different configuration: AC voltmeter, DC voltmeter, AC ammeter, DC ammeter, and measuring of the resistor, testing of diode connectivity, and testing of transistor. All these things can be possible, and these are all the probe used to test, and these are all the values adjustment. This is AC voltmeter. If the knob is in this position, it measures the AC. If this knob is in this position, it measures the DC current. And it's a continuity test. Here it is a continuity test. This is a ohm meter. It acts as a ohm meter, and it's a DC voltage. And this is for off. So this is a multimeter we used in our laboratory. LCD display, it displays the values in a digit. It's a digital multimeter. There are different types of multimeter. There is an analog multimeter as well as digital multimeter. We use digital multimeter in our laboratory. And motor, there are different kinds of motor you have seen in your home and in your electronics laboratory. It's a stepper motor, AC motor, DC motor, all these things. All this motor have a coil having a permanent magnet or a conductor for followed conductor surrounded with a coil that is acts as a magnet when the current flows through that coil. So this is the motor, and this is the symbol circle having written M, that means indicated motor, and circle with a M with a followed with a positive and negative, it's a DC. DC motor have a polarity, and the AC motor doesn't have the polarity. And a breadboard, this is a kind of board we use to bring up the circuit diagram to test our electronics experiments. These are all different dotted point in a dotted hole. This dotted hole is used to place the component and bring up the circuit. This internal connectivity in this breadboard, it's like this. So this is like a vertical point, and this is horizontal. These are all, we call this is a power line, or we can use this for ground line. And these are all vertically connected. This is way internally connected. We can place the component and we can bring the circuit diagram and we can test it. This is the breadboard. And coming to soldering gun, say to develop the PCB or printed circuit board, or to want to solder electronic circuit diagram, we use the soldering gun. And this is a complete set. The soldering set, it's a soldering lead and a wax soldering gun, and electronics component we use to solder it in a circuit diagram. And spike booster, this is a spike booster. Or if you want to connect multiple uh, devices in a single socket, they use this spike booster. The spike booster have a fuse. Here you can see red color, this having a fuse. This acts as a protecting for this devices. And in this spike booster, each connecting socket have a switch. It can be single controller. For this, one switch controls all the connecting. This is a spike booster. That's all. Thank you.